Hello everyone and welcome back to my YouTube channel. And in this video, you're going to building here a project that's called the traffic sign recognitions using deep learning. And this is a demo applications built by using Flask and Python. And you can also choose the images from your directory. And when you click predict button, and it will try to predict the images that you selected. So if I click here to predict, and you can see here the speed limit is 50 kilometer per hour. And this is nothing but a traffic sign for that. If I select here another photo, so let's say select here the another photo and this one. So this one is speed limit maybe 80. So you can see here end of speed limit 80 kilometer. So let's select another photo. So let's go down. Let's select for 35. And if I click it to predict, and you can see here ahead only. That's mean it is really working fine. And in this tutorial, you're going to be building these full projects from the scratch using deep learning. So without wasting any time, I'm going to start a tutorial now. All right. So in order to building the traffic sign recognition project, you're going to using a dataset from Kaggle that's called the traffic sign dataset classification, which has around 58 classes, and each classes has around 120 images. So if I go down, you can see here, this is the dataset, and also having one CSV file. So which one containing the two columns, class ID and the names, and having the 57. Okay, 57, right? Started from 0, that's been 58 classes, and all the classes have their class names or their corresponding ID. But if I go inside my traffic data folder, you can see it have 35 folder. That means some folder are missing because it had the 58 columns, but the folder have the 35. That's means some column are missing. So that's why this data set is not perfect or well organized. So I collect the data from the another sources and upload it in my Google Drive, where you can download the data set, and which having the 43 classes and also the levels file like that. Okay, so you can also use this data set, and you can check that you can delete some data from here. That's why I actually cut and paste all the things and make the data set perfect for you. So now, without wasting any time, I'm just going to go on my folder, and after that I'm going to go on my VS Code. So let's go. So this is my data set, and you can see here also the levels file and also a data set. So which having the 0 to 42, that's mean it have 43 columns, I mean 43 classes. And if I go inside 0, it have the 20, I mean speed limit is 20. And you can say 26, it have some another types of traffic sign. So if I go on my labels.csv file, which having the corresponding class ID and also the name. I mean class ID is nothing but my folder, I mean folder name, and name is nothing but my class name. I mean 0 means inside this 0 folder it have the speed limit 20 kilometer files are available. Now what we're going to do here, we can simply building our model using CNN, right? We're going to building the model using CNN and Python. So what I'm going to do here, I'm going to just open my VS Code. So right now I am on my VS Code, and I already do the coding part here. So this code is nothing but for the training the model. And after training the model, you're going to building here our Flask applications using Python, right? So you can see this is a code, simple code, which having some CNN model and also data pre-processing and also the data loading. So this is nothing but for the library. So we import here some necessary library. We import here the NumPy because you need to convert this data into the NumPy array, because a computer does not know the images. It's know the binary digit or the numbers. So that's why you need to convert these images into some NumPy array. And also the matplotlib pyplot in order to show the accuracy curve, loss curve. That's why. And we're going to import here from keras.model and import the sequential. So there are two types of model are actually available you can build. One is functional and another one is called sequential. Sequential means that you're going to pass in the data from one layer to another layer. So that's why import here the sequential layer. Then we have the dense layer. This is the final layer. I mean how many output and how many input that you're going to pass. And also here one optimizer, it actually help you to optimize your loss, I mean your cost function you can say. And you're going to using here the atom. And then you have the two categorical, because this is not a binary classifications, it multi classification. It have nothing but 43 classes. That's why I need to convert this into the categorical format. So that's why I import here the from keras.utils.nputils, you import here the categorical. Then we have the dropout in order to remove or in order to reduce the overfitting problem uh, to it actually happening in the deep learning process. So that's why I actually import here the dropout and also the flatten layer. So when you passed here one image, it should be a multi-dimensional array. But when you put it inside on CNN, you need to reshape it. You need to make it in a one single vector. So that's why we import here the flatten layer. Then we have the convolution. Obviously, this is for the convolution operations, and having the max pooling 2D, it is for the pooling operations, right? Maximum pooling. You can using the average pooling. So many pooling layer are actually available. I am just going to using here the max pooling layer. Then you have the CB2 in order to load the images. Then this is the most important one: train, test, and split. See, one thing, when we are building one machine learning model, we need to divide this data set into two format. One is the training, another one is the testing, or you can do in the three format: training, testing, and also the validations. So that's why I import here the train, test, and split. Pickle, we don't need it. Pickle. You can also use the pickle if you want. If you wanted to save the model in the pickle format, you can also do it, but you're going to save it in each 5 format. So you don't need this pickle one, right? Then we have the OS because we're going to be loading the images from our dataset folder. Obviously, we need the operating system. And we have the pandas because we are loading one CSV file. So you need to loading the CSV file. Obviously, pandas is needed. And random, I think it's not needed. Then we have the pre-processing images. Even using here the image data generator. So this is the most important one. So see, we have the 58 classes that you see in here, but in this folder, I mean in this data set, it have 43 classes. Each classes containing 120 images. That's mean there are limited number of images, right? There are limited number of images. So if we're trying to actually increase the data set, we can use the data argumentations. I mean, you're going to zoom, you're going to share, you're going to rotate the images and making one another images. That's been data argumentation. You're going to increasing the data. So in order to increasing the data, you're going to using the image data generator. That's why you're going to using here the image data generator. Now we actually give here the path. I mean path that's called the e data sets, and also my level file, levels.csv, the batch size. Batch size is nothing but how many images that you're going to put it inside your training. Let's say I have on a GPU from the NVIDIA company. So it will support 64, the highest batch size. I mean, in each time it will load the 64 images. So I give here 32. That's mean 32 images should be loaded. You can give here 100. You can give here the 1000. It's up to you and up to your GPU performance, right? And epoch value 10 and image dimension 32, 32, 3. See, if I go here, it have some images. Maybe this all images is not in the same size. So what you need to do? Obviously, you need to resize them in the same format or same sizes. So that's why I'm going to give a 32 cross 32 cross 3. 3 mean 3 channel RGB, red, green, and blue. Simple. And you can see here task ratio and the validation ratio if you want to do the validation part. Then what you're going to do, you're going to simply loading the data from our directory. So for that, we need to create here two classes and two lists, sorry. One for the images and another one for class number. So images mean it having the image name in a one single list with that corresponding image list, it having one class number, so that we can divide them into dependent and the independent feature, right? And count here, I mean how many images are counted. Then you're going to go inside my voice.list, inside this path, and it will create a list for that, and it will try to print the length of the total class detected. Then number of classes and how many classes are inside this folder. So that's mean this my list actually give here my count of the list. I mean how many folder are available inside my dataset folder. So it having a start from 0 to 42, that's mean 43 classes. So number of classes should be the 43. Then what it can do, it can go inside all the folder and it will try to read all the images, and after that it will append the images with their corresponding id, and after that it will actually convert them into the numpy array, right? After that it convert them into the numpy array. See, again, we create here two lists, images and the class number, and we have one, we are going to do the list of the data. Let's say we have the image from 1 2 like that. That's the folder. So to create one list for that. After that, to up to 43, up to 43, up to 43, 43 or 42, 42. So it is creating one list for that. And after creating the list, it will calculate the length. So how many lengths? 43. Number of classes should be 43. Now it will go inside the 43. It will call in this loop for the 43 times. And after that, it will go inside this folder, zero folder. Then inside the zero folder, it has some images. Then it will iterate to all the images and it will read all the images and paste it inside the images list and with their corresponding class list. That's mean, let's say I have my images. So that's I have my images having some random value. Let's say 0 0.5, 0 0.6, 0 0.7, 0 0.8. This is nothing but my images. Let's say this is my images. So with their corresponding array, let's say this image is coming from 0. That means this list is look like that. Then what I can do? We can simply give this kind of value and it will give me the predictions 0, 1, 1 like that. Simple. That's why you need to divide them into the images into the class numbers. Then we're going to simply convert them into the numpy array so that we can split it, right? So if I comment out these lines, comment out those lines, and try to run the code, just comment out those lines. And if I go here and you can go on the terminal, new terminal, and you can type here the python app.py. No, python main.py. So let's type it. Well, so python main.py. So it will loading the data from my directory. Just a while because it will load in the TensorFlow. So total class detected 43. I mean 43 classes are detected, and now it will importing the classes. Then how many images are actually inside this folder, right? Then what I can do, we can simply now split the data set into train, test, and validations, right? Train, test, and the validations. So let's import it. Okay, it's important. It's try to import the class, and after that you need to load this, right? So if I go here, this is the Jupyter notebook. You can also run this code in your Jupyter notebook or Google Colab. So you can see just a while. If I go down, you can see here it imported all the classes like that. Because this is the BS code, that's why it's not showing up, right? So it's look like that, right? So now what I can do, we can simply divide this data set into train, test, and split. Okay, so this is one X train and the Y train, and sorry, X train and the X test, and Y train and the Y test. Then you're going to pass here on images and the class number and also the trace ratio. Now we need to also divide the data set into validation one so that we can validate it, right? We can validate it. So this is the new one, right? This is a new process that's I don't do ever in my any of the projects. So X train and the X validation and Y train and the Y validation. See one thing, we pass here the images and also the class number inside the train, test, and split. But when we do the validations, we pass here the X train and the Y train. To pass here my X train and the Y train, because in the same data, we're going to getting the 20% from that. That's mean we have 60% for the training, 20% for the testing, and 20% for the validations, right? Then we just simply printing here the data shape and how many train, how many shape for the validations, and how many for the test one, right? Then simply we are going to reading all the data from our label file and try to print the shape of that, right? Simple. Now what I can do, we're going to do some pre-processing on the data. You can use the OpenCV in order to pre-process data, or you can also skip that, right? So what you actually do here, first you can do convert this data into the grayscale. See, this is nothing but one RGB images. This is one RGB images. So you can be using here some popular CNN technique that's called linear architecture. So that's why you need to convert them into the grayscale format, right? This is the new one. So when you're trying to predict one sign recognition types of data, you can use this code. You can use this code. That is really working very fine, like hand sign recognitions or digit recognition or the traffic sign recognition. Any kind of recognition, this linear architecture all working very fine. So that's why you need to convert them into the grayscale format. And after that, we're going to equalize it. Then we're going to define here one functions which on grayscale it and equalize it, right? Equalizations. It also one OpenCV technique. right? Then we can simply divide them data set into the 25, so that this data is going to normalize. This data is going to the normalize. So the maximum value of the image should be the 255, right? And the minimum is 0. 0 to 255. If I'm trying to convert them into 0 to 1 range, so what should you need to do? Simple math. Simple math. We need to divide them into 255. Again. Let's say I have one value from 0 to 10. 0 to 10. I am trying to make this range between the 0 to 1. So what should we need to do? Simple, we need to divide them all the value by maximum number. Let's say 0 by 10. Then what I can do? 1 by 10. Like that. Like that. That's mean it will convert it into the range between 0 to 1. 0 to 1, right? So this is how we are going to pre-process our data set. First we convert them into grayscale, then equalize it, and after that we divide them into 255. Now our data set is between 0 to 1. Now we can simply reshape the data set and pass it inside my CNN, and CNN will extract the feature from our data. Now what I can do, we can simply pre-process the data set using one list map and p.array, and we're going to apply it all the value. I mean all the value, all the images, X-train and the Y-train. So pre-processing part is done. It's nothing but the reshaping. See one thing, when you pass any data inside the CNN model, this is the necessary one. How you're trying to do that? Let's say I have one images, 32, 32, 3, 32, 32, 3, right? So when you pass this data inside the CNN, so you need to also pass the data with their corresponding image size. So n. So n is nothing but by how many images you are going to pass it inside the CNN. So this is called the reshaping. See, we actually pass here by reshaping button. Xtrain.shape 0 and xplantation.shape.0 and x-shape.0. Right? Why? Because you need to pass the file. How many files you're going to pass it inside your CNN model? That's called the reshaping. Again, when you're trying to building one CNN model, you need to reshape your data. If your data is right now in 32 cross 32 cross 3, you need to reshape it n cross width cross height cross channel. N is nothing but number of images. 32 is nothing but by width of the images. 32 is the height of the images, and 3 is channel. I repeat this thing again and again because this is the most important part. So that's why. Okay, fine. Now this part is nothing but for the data argumentation. Let's say I have 120 images. I'm going to generate more 102 images more. Let's say 300 images. So for that you can use this data argumentation. That's called the image data generator. So you can pass here some parameter. Let's call width shift range, a height shift range, and it can zoom it can shear it can rotate the images, and generate so many images. Then what you can do, you can simply flow a data gen flow that feed the X train and also the Y train, and you can flow from the directory, flow from the dataset directory, and it will try to generate all the images. Now the last part, it's called the two categorical. So because this is one a multi-class classification project, so that's why what you need to do, you need to convert this dataset into categorical format. So that's why two categorical format is arrived in the scene. Two categorical. Don't worry on the code, you'll get this code in the video description with the GitHub link. Don't worry, you can just go on here and copy the code. But one more thing, just remember the thing, just understand all the code line by line, because this is very important when you sit in interview or when you sit regarding your final projects, anything else, right? Then what I can do, we can simply building our model. Simple. So we actually initialize our sequential model, and this is nothing but my input layer. So if give here the 16 number filter, single number kernel, and it have the 5 cross 5 filter and image dimension 0. Image dimension 0 is nothing but means if I go up, you can see our image dimension 0. That's means 0. This one, 1, this one, and this one is nothing but 2. So you can see here, just go down. Okay, this one image dimension 0, image dimension 1, and 1. But why 1? Maybe you need to give it 3 because we are going to dealing with the RGB images. No. Why? Because you go up, you can see here we convert this image into grayscale. That's mean our channel right now convert it into the one. It's not a RGB image right now. It is right now one grayscale images. So that's why we pass here one. And this is one trick. Okay. Also one catch. And activation function is a ReLU activation functions. Then we add here another layer for 60 and 55, and activation is a ReLU. And we add here one max pooling layer. Again, 60 kernel, 55 filter, and input shape is nothing but 0 and 1. Then we add here the divide by 2, 60 by divide by 2 is nothing but 30, same. And also kernel is 3 cross 3, and you get here one pool size. And also give here one dropout so that it cannot be overfitted the model, right? Then what you can do, you can simply flatten it. You can do making it in one single vector, and after that you can do pass it inside the dance layer, and also give here one dropout. And simple, this is the final layer. Model dot add dance number of classes. How many classes are here? So you can give here 43, but the 43 is already available inside my number of classes variable. So if you go here, you can see here the number of classes. So that's why. And now if I go down, you can see here activation function is nothing but softmax. But why softmax? Because this is one multi-class classification. If there is a binary classification, so what you need to do, sir? You need to keep here the sigmoid. To keep here the sigmoid. Then what you're gonna do? You can simply give here the loss, the categorical cross entropy. Again, if it is binary classification, obviously that should be the binary cross entropy. Then make sure when you build a model, you need to also compile it. You need to also compile it before fitting it inside your data. Then you can see the your model summary, and we use the feed generator. Why feed generator actually? Because we are going to load the data using our image data generator, because it will automatically generate the data, but it's not storing inside my dataset folder. It will store it inside the memory. So that's why you need to use the feed generator and flow it from our dataset. And you pass here my X train and the Y train, and the batch size is nothing but 32. You can give here 32 also. Step part epoch is nothing but length of the X train divided by 32. 32 is nothing but my batch size. And epoch is epoch bell, maybe 10. And this is one validation data, X validation, the Y validation, and shuffle is equal to 1. It can shuffle the data. So this is the code for the accuracy curve. And you can also show that your model evaluation. You can also evaluate it using your testing data, and you can also check your testing score. And finally, you're going to save the model, right? So this is nothing but for the CNN. You can see plot the loss curve and the accuracy curve. This is, you can copy this out, right? So now what you're gonna do, you can simply run this full file, but it's better you can run it in the Jupyter notebook. So that's why I actually show it up, and I actually teaching you this code in the VS Code, because this interface looks very cool. So that's why. Now I'm going to open my Jupyter notebook and try to run the code on here. You can also run this code from here. Just clicking on this button, and it will automatically run the code from here. So I'm going to click it to close it, because when you're trying to do any code for machine learning or data science or the artificial intelligence, I recommend using the Google Colab or the Jupyter notebook. Don't use the BS code, right? Don't use the BS code. Just for the explanation purpose, I may use the BS code, because this screen looks very good. So see, okay, it also importing all the classes. Let's see and try to run this code in the Jupyter notebook. That's why. Okay, let's try to import it. Okay, you can see here the training shape. See, this shape is nothing but my n, and also you can see here the sequential model is sequential, and this is our model, and it also start the training part, right? So I'm going to click it to close it right now, and try to go on my Jupyter notebook so that you can see it correctly, right? So you need to open the Jupyter notebook. You need to just click on here and type here the CMD. It will open your command prompt, and you need to type here the Jupyter notebook. You can also run the code on the Google Colab. Just need to upload this file in your Google Drive, right? Okay, just open this one and try to go on the full screen mode. So this is the code right now. So what I'm gonna do, I'm simply going to shift enter into running the code. Shift enter. This is a shortcut in the Jupyter Notebook and also the Google Colab. So it will loading all the files from the dataset folder, and it will store this file inside your model.is5 file. So you can see it actually importing the classes that's been importing the images from the directory. Okay, so after importing that, it will pre-process your data and also give you keep here one accuracy curve or the loss curve like that. So I will train the model before that you see the accuracy graph and also the all the things are actually appear. So I'm going to using here my model.is5 file. So using this file, I can actually testing it out in any kind of devices, so that I don't need to actually train the model again and again. Right? You can see here the shape. This is nothing but a shape, and you can see a shape is nothing but 22271. So this is nothing but my number. So this number is actually passed it inside my CNN model, because you need to reshape the data. So that's why it is the reshaping after right after reshaping this data is look like that. And you can see here this is the class pandas, the numpy like that. Okay, and this is my thing about my convolution layer, how many parameters are available. And you can see here it will take 2 minutes. So after for 10 epochs it will take maybe 20 minutes. So I'll back after 20 minutes later on, and you're going to building here our Flux applications and also try to test it out in real time. Okay, so all right, so after it will take more than 25 minutes to training the model, and this is the curve for the training loss and also the accuracy. And it got the accuracy nothing but 98%. That's really very good. So after actually training the model, what you can do, we are going to building here our Flux applications. So after training that, we get here one file that's called the model.is5 file. So you can also share this file with your friends or with your teachers. He actually used this one model file to train that, to actually check that, I mean testing out in your new data. So now what we're going to do, we are going to simply building here our Flux applications. So well, so you can see here the model.is5 file. If I open it out, it will actually opening this file in a one applications that's called the Netron. So this is nothing but my model. Okay, and you can also zoom it. Okay, you can also zoom it, so show that. Okay, this is the model that's look like, having the two layer comp2d and the comp2d, and you can see the filter all the things. So now we're going to using this model to test it out. And you can see here actually passed here the two folder, static and the template, and also another folder that's called upload. It will actually store the images that you uploaded, right? So inside the static folder, it having the your CSS and the JavaScript file, and inside this template you have the base.html and also the index.html file, and another file is called the app.py. So I'm going to open with the code, and this is the code. If I open my app.py, and you can see here this is the code. So what is actually Flux? Flux is nothing but one micro framework. Using this you can create the API, right? You can also do the web development. You can do it using Flux and Django. So Flux is easy better than the Django. So that's why I'm using here the Flux. So see, that's really easy. So when you upload one images, you need to do the same procedure that you do while you're training the model. So what do you actually do here? We first load the images, and we actually convert them into grayscale and equalize it and also divide by 255. If I go on my app.py file, you can see here same things: the grayscale, the equalize, the pre-processing, and also the get class name, right? And you can see here we actually load here the model file that's called the model path equal to model.as5. That's actually available inside my folder. And we actually import here the from TensorFlow.keras.model. We're importing here the load model. We don't need the pre-process input because we don't use here the transfer learning method, and we have our own pre-processing functions. So that's why you don't need to do it, right? So you have the random template because it will load here the HTML file. That's why you can be using here the random template. And make sure when you pass your HTML file, it's always inside your template folder. Then what do you have? We have our load model. We load the model, and you're going to initialize here all the functions that's called grayscale and also equalize and also pre-processing. Now we're going to pass this pre-processing in our images. If I go down, you can see here these are functions for the model predict. See, it will load the images, image.load, and you give here the target size nothing but chord 224, chord 224. So it should be nothing but the 32 cross 32, right? 32 cross 32, and it convert them into the image to array. And after that, you're going to actually resize them into 224 chord 224. You can also make it 224 chord 224. That's not a problem, because it is loading the images into 224 cos 224 cores, because you're going to using the same formula in the transfer learning. So that's why the target size is nothing but 224 or 224, right? So but we resize it, right? We resize it 32 by 32. So that's why my image size looks very bigger in order to show in the web applications. So we resize it by 32 by 30, because our model is training on the 32 by 32 sizes. So that's why. Then we actually pass here my pre-processed images that is coming from here, choosing images. Then you can be simply using here the reshape it. So see, reshape one thing, one is nothing but one single images. That's mean in the application it can just predict one single images. That's why n is nothing but one. 32, 32, and 1. It's one grayscale images. When actually give here one RGB images, it automatically convert this image into grayscale. So that's why 1. Then simply predict, and you can use the predict class. Maybe this predict class is not working on your case. Maybe this predict classes is not working on your case. But it give me one error that called a sequential object has no attribute called predict classes. So what can you do right now? What can you do this time? You can do np.argmax. You can do np.argmax. You can do it, right? But if you're using my same version that I'm using, my Python version, my TensorFlow version, my Keras version, it will work, right? So let's see my Python version and also the TensorFlow and the Keras version. Just install this version. This code is working very fine. But if you are using any newer version of Python, so you can use these predict classes. You know, to using here the np.argmax. Then you need to pass your x train and also your y train, and you can get here one class index, because in the upper version it will actually remove these predict classes. Don't worry, I'll make one video on that, how can you remove this kind of problems. So let's see my Python version and also the TensorFlow version. So for that, I'm going to open my command prompt, and I'm going to type here Python, and my Python version is nothing but Python 3.8.5. So if I'm trying to import here my TensorFlow, so let's say import TensorFlow, TensorFlow. So this is my TensorFlow, and in order to checking the version, I need to type here the TensorFlow dot underscore underscore version. So let's say TensorFlow dot underscore underscore version. So B should be the small, and this is my version of TensorFlow that's called 2.3.0. And let's check for the Keras version, because this code is running on the Keras, and TensorFlow is the backend right now. So I'm going to import here the Keras right now. So import Keras, and that's the Keras dot underscore underscore version. That's it. And my Keras version is 2.4.3. Remember one thing: Python 3.8.5, TensorFlow 2.3.0, and Keras version is 2.4.3. Right? Remember this one. Let's close it. Okay. Then we have one get method. It will actually render the index.html file, and there is one predict button. So when you click the predict button, it will give me the get and the post request, because we're going to predict it. And after the file is a post, that's mean we're going to store the file inside my folder, upload folders, and it is actually saved file in the upload folder, and it will predict them. And based on the predictions, it will give me the answers, right? And this is having one class name. So if I go here, you can see a get class name is called. I just pass here my class index, and you can also check the probability value. You can also check this out. So I just comment out this line because we do need the probability. You can also do this code, the same code in the real time. You can also test it out in the real time also. So there's also one code for that. I'll give this code link in the descriptions. You can get the code from here, to run this code in the real time. That's your task to do that, right? So now what I'm going to do, I'm going to simply go on here. Okay, I can also run from here. because it will automatically run the file from here. So it will give me link, uh, one local host link. So in order to clicking this link, you can actually open that. Okay, you can see here my web application is look like that. Let's go on the full screen mode, and you can see traffic sign recognitions using deep learning. If I click at the choose one images, so let's choose one images from here. Let's choose this one. Okay, and try to predict. Okay, turn left ahead. Oh, that's working fine. Okay, let's select another one from the four. Which is the one? It's 70 maybe. Wow, speed limit 70 km. Let's go and try to select another one. You can check it out using another kind of data or new data. You can also do it. So let's select another photo. This is nothing but for by testing purpose, right? Uh, let's from the 40. That's this one. Okay, predict and run the bound mandatory. So that's really working fine in this kind of cases. You can also check this out in the real time. You can show your camera and you can give your traffic sign, and it will predict the traffic sign for you. So that's it for today. Now hope you enjoy this tutorial, and make sure to subscribe to the channels, and don't forget to hit the bell icon. And I'll be back with another tutorial. So till then, take care and bye bye, and thank you.